Okay, let's take a look at the next section we're going to have a look at doing. This is finding the point for a given gradient. So what that means is, let's say you're given an equation. Let's say the equation is y is equal to x squared plus 3. Yeah. So there is our equation. And let's say we're told that the gradient is a certain value. And what we have to do is find the point for that given value. So let's imagine, for example, we're told the gradient, the m value, is 2. So we want to find the point on this graph here where this is true, where the gradient is 2. Well, let's find out. So let's have a look at ways we could do that. Well, of course, the way which I would like to do it using calculus is to take the differential of this. So we're going to take dy dx. So suddenly this here is the equation of the gradient. This is the gradient equation, the gradient function, if you like. So we know in this case what the gradient is. So rather than leaving dy dx, I know the gradient is 2. So I'm just going to write 2 is equal to 2x. So now we can solve for x, and of course x is going to be 1. Divide both sides by 2, 2 divided by 2, 1, and we have x is equal to 1. So now we've found the x value for when the gradient is 2. So to find the y value for which that is true, we're going to feed this back into the equation and substitute for x. So then we're going to have the y value for that point. So let's have a look. So far we've got an equation. We're told the gradient is going to be 2 somewhere on that equation, and we're being asked, what is the point where on this equation where the gradient is 2? And what we've done is we said, well, let's find the gradient function for this equation. There's the gradient function. We've just taken this and differentiated. There it is. And we've substituted in the gradient, which is 2. So we've written in gradient is 2. There it is. We've written in is equal to the gradient function. We've solved for x, and x is 1. So now we know the value is x is equal to 1. And all we have to do now is find out what the y will be when x is 1. So let's do that now. So I'm going to restate it. Here we go. Y is equal to x squared plus 3. I'm substituting the x value here, 1 in for the x value, so y is equal to 1 squared plus 3. Well, 1 squared is 1 plus 3. Y is 4. Now, really important at this point, not to say, well, x is 1 and y is 4, but write it as an ordered pair. In other words, we're going to write it as a set of coordinates. So here we go. So therefore, we can say the point on the function y is equal to x squared plus 3, where m equals 2 is, and now we can have that coordinate, 1, 4. And there's the result, there's the answer. So it's very important, of course, to put this bit here, the point on the function, or the point on the equation, if you like, where the m value, the gradient you might write, is equal to 2, is, and then the ordered pair, the set of coordinates where that would be true. And that's how we state our answer. Now, what I'd like you to have a shot at here is these equations here. So this is exercise, this is theta. So this is theta here, theta book, theta text, exercise 21.02. I'm going to include this, and I'd like you to have a go at these. And so here we're going to write the coordinates of the point on the curve of blah, where the gradient is 7, or where the gradient is -5, and so on. And just work your way through. Do the whole lot. There's only a few there to do, but this is very, very good practice, especially leading into the next topic, which is finding the equation of the tangent at a curve. So that would be the next thing we're going to do. This leads in perfectly, so make sure you have got this bit sorted. Okay, folks, give it a go, and we'll talk soon.